So, you brought this to our attention, this whole idea of improving reliability, especially when we're talking about heavy manufacturing.
Yeah.
And, it really piqued our interest. We dug in, did some research, and what did we find? A brand new case study, like literally updated today.
Yeah, just came out March 25th, 2025.
Enhancing Equipment Reliability in Heavy Manufacturing, CMR.
Catchy title. Right to the point. What really stood out to us right off the bat was how this leading company, I mean, they're a heavy hitter in their industry, decided to confront a challenge that's, well, it's almost universal in heavy manufacturing. They were looking at how to keep their, let's face it, massive and complex equipment running smoothly without, the constant threat of breakdowns derailing everything.
Right, because those breakdowns, they have a ripple effect. And this case study, it doesn't shy away from that. It dives right into the core problem they were facing. They were always fighting against these unexpected equipment failures, weren't they?
Absolutely. The report makes it crystal clear. These failures were like a domino effect. It wasn't just the production grinding to a halt, which is costly enough on its own. It was the immediate need for emergency repairs, which, let's be honest, those never come cheap. And then there's that overall drag on their efficiency. You get this sense from this study that they were constantly playing catch-up, always reacting to the latest crisis.
It's that classic reactive mode, and it's a tough cycle to break out of. And then, of course, they start talking about why the traditional approaches to maintenance, like preventative maintenance, those just weren't delivering the results they needed anymore.
Right. You hit the nail on the head. It's like this constant tug of war. Are you doing too much maintenance? Spending time and resources on equipment that's humming along just fine? Or are you not doing enough and things still break down when you least expect it?
And the case study points out how these older methods, they're often tied to, these rigid schedules, no matter what the actual condition of the machinery is. So you end up with this weird situation where you're either overspending or you're still getting those in-service failures that, ironically, preventative maintenance was supposed to, well, prevent.
It highlights the disconnect between a fixed calendar and the real-time needs of the equipment.
And then there's the big one, the thing everyone dreads. Reactive maintenance. It's
Yeah.
like when your home appliance suddenly dies on you. You're stuck and your whole routine is thrown off. But on an industrial scale, it's obviously way more disruptive. The case study really drives home just how much havoc these unplanned outages wreaked on their production targets. And we're not just talking about internal targets. This impacts their whole supply chain, doesn't it?
It ripples outward. What struck us is how this created a real sense of urgency. They weren't just looking for a small tweak here or a slight improvement there. They recognized the need for a fundamental shift, a way to take control and minimize these costly disruptions that were impacting their whole business.
And that leads us to their big solution, the decision to move towards a predictive maintenance system. And this is where things get really interesting because they're not just slapping on a new coat of paint here. They're talking about a paradigm shift driven by artificial intelligence and machine learning.
Absolutely. It's a whole new approach. Their objective, as outlined in the study, was to stop being reactive. Forget the fixed calendar. Instead, they wanted to use real-time data to understand the actual health of their equipment and predict, with a high degree of accuracy, when maintenance would be required. This is the essence of a condition-based maintenance model.
And the benefits they were aiming for were pretty significant, weren't they? Obviously, improved reliability is at the top of the list, but they were also looking at a dramatic reduction in maintenance costs, extending the lifespan of these very expensive assets, and just an overall boost to their operational efficiency.
It was a bold vision, and the case study makes a very compelling case for why this approach was so attractive. If we zoom out for a moment, this move towards predictive maintenance really reflects a larger trend we're seeing across industries,
Yeah.
using data to optimize complex operations. But the real nitty-gritty, how they pulled this off, that's where it gets truly fascinating.
So let's dive into that methodology. Step one, data collection and sensor integration. It sounds like they went all in, deploying a network of IoT sensors across all their critical machinery. We're talking production lines, those giant industrial motors, hydraulic systems, even the conveyor belts.
They really went comprehensive. The detail in the study about the sheer scale of their sensor deployment is impressive. The goal was to capture this incredibly rich stream of data that could paint a really detailed picture of their equipment's health. And the types of data they were monitoring, it gives you a real insight into the critical factors in heavy machinery. For instance, vibration patterns. Like, think about it, your washing machine at home. When it starts shaking violently, it's usually a sign something's off balance.
Makes sense.
Similar subtle changes in industrial equipment can be early warnings. So they're tracking those vibrations. Then temperature fluctuations, because overheating is a big concern. And then pressure variations within their hydraulic systems. They even monitored energy consumption. Now, that might seem a bit indirect, but it's actually quite clever.
How so?
Well, changes in energy consumption can sometimes be an indicator of inefficiencies or even hidden problems developing within the machinery. And they didn't stop there. They also looked at things like the viscosity of fluids, which tells you a lot about the health of the lubrication systems.
That's a lot of information flowing in. And of course, it's all being streamed to a central cloud platform.
Right, that's the logical choice for processing and analyzing this massive amount of data. But what's equally important is that they didn't just rely on this constant influx of real-time sensor data. They took a step back and said, okay, we have years of maintenance record. That's valuable information. So they integrated those historical records into the system.
That's like giving the AI a long-term memory, isn't it? Like access to the company's collective experience.
Exactly. By combining that live data with the historical data, with all the lessons learned from past failures, this system could start to pick up on patterns and correlations that a human analyst might miss. It's about connecting the dots in a way that was never possible before.
Okay, so they've got this flood of data coming in. Now comes the really smart part, building the machine learning model. The case study mentions they used both supervised and unsupervised learning. Could you break down what those are in this context?
Sure. Think of supervised learning like this. It's like you're showing the AI examples and saying, see, this is what a problem looks like. You're feeding it data from past failures, like here's what the vibration data looked like just before this bearing failed. So the algorithm learns to recognize those specific patterns. And when it sees something similar in the new incoming data, it can flag it as a potential issue.
So it's trained to spot the known issues.
Precisely. Now, unsupervised learning, that's a little different. It's more like you're giving the AI a big pile of data and saying, okay, go explore, see what you can find. It's not looking for specific pre-labeled problems. It's looking for anything unusual, anything that deviates from the norm.
Like an anomaly detector.
Exactly. Imagine it sifting through all that sensor data and noticing, let's say, a weird pattern in the energy usage of a particular motor. It doesn't quite fit with what's considered normal. That could be an early warning sign of a new type of problem, something they haven't even encountered before.
So supervised learning is for the known threats, and unsupervised learning is like a safety net, catching those unexpected issues.
It's a really clever two-pronged approach. And the case study stresses that these models, they weren't static. They were constantly being updated as new data became available. That continuous learning, that adaptability, it's vital for staying accurate over time. Because, let's be realistic, equipment ages, operating conditions change. So your predictive models need to evolve too.
Makes perfect sense. Now, they also mention using some pretty advanced techniques. Deep learning, things like convolutional neural networks and recurrent neural networks. Sounds complicated.
It is. These types of neural networks, they're really good at handling those massive, complex data sets. They can find those subtle, hidden relationships that might point to a future failure. Think of CNNs like a really sophisticated pattern recognition system. They're good at seeing those patterns in the sensor data, much like our brains recognize objects in an image. So they can analyze those vibration patterns, the temperature readings, and look for even the slightest anomalies. And then you have RNNs, which are amazing because they're all about sequences. They understand how things unfold over time.
So not just a snapshot, but the whole story.
Right, and that's essential for predicting those failures that develop gradually, like a slow increase in temperature that eventually leads to a critical overheating event.
So you've got this AI that's always watching, learning, and looking for anything out of the ordinary. But what happens when it does spot a potential problem? That's where the real-time predictive analytics and alerts come in.
Absolutely. The system is constantly analyzing that incoming stream of sensor data. It's looking for any deviations from what's been established as normal operating parameters. When it finds something that suggests a problem might be brewing, boom, it automatically generates an alert.
And these aren't just vague warnings, right? The study was very specific about this. The alerts and notifications go directly to the maintenance teams. They're using dashboards, email, mobile apps, all those channels that get the information where it needs to be fast.
Exactly. They're not waiting for someone to happen to notice a problem. The information is pushed out proactively. So the maintenance teams can respond quickly, address the potential issue before it escalates and causes a major disruption. It's that shift from reacting to problems to actively preventing them.
This is where the predictive really comes to life. They're getting a heads up, not a postmortem. But it sounds like it took it even further with automated decision-making and workflow optimization.
Yes, and this is where the integration with their existing systems becomes really important. They tied this predictive system into their ERP and their CMMS, their computerized maintenance management system.
Hmm.
So the AI isn't just saying, hey, something's off. It's providing specific recommendations. It might say, okay, based on this data, here's the most likely problem, here are the parts you'll probably need to fix it, and here's the optimal time to schedule the work, and even who should do it.
It's like having a super efficient maintenance planner, right?
In a sense, yes. And this really helps them move away from those rigid, calendar-based maintenance schedules. It's all about condition-based maintenance now. You're only working on equipment when the data tells you what's actually needed. That eliminates a lot of unnecessary work and potential downtime.
And the system isn't just sitting there static. There's a constant feedback loop, which has to be incredibly important for ensuring it stays accurate and relevant.
Absolutely. The system is learning from its real-world performance. So the maintenance teams, they're providing input, their on-the-ground expertise, and that's fed back into the AI along with the actual data from how the equipment performed after the maintenance. It's a closed loop, a self-learning system that gets smarter over time.
Okay, so they've built this impressive predictive maintenance system, but how do they know it's actually working? That's where the data validation comes in.
Right, you have to measure to manage. The case study is very transparent about how they went about proving the effectiveness of their approach. They did something called correlation analysis. Basically, they were comparing the AI's predictions with the actual historical failures. They wanted to fine-tune the models, make sure they weren't getting too many false positives or false negatives.
So not crying wolf too often, but also not missing those real problems.
Exactly. It's about finding that balance, that sweet spot where you can trust the predictions. And then, of course, they did pilot testing. Before they rolled this out across their entire operation, they implemented it on a smaller scale, a representative sample of their equipment.
A real-world test drive.
Exactly. And they tracked those key performance indicators we talked about before. MTBF, mean time between failures, MTTR, mean time to repair, and the actual cost savings in their maintenance operations.
In the pilot program, those early results, they must have been pretty encouraging because they decided to scale it up.
They were. The study reports a significant reduction in unexpected breakdowns during that pilot phase. It was clear, data-backed evidence that this predictive approach was working. It validated their investment and the entire strategy.
Then they didn't just look at the numbers, did they? They also got feedback from the maintenance teams, the people who are actually using the system every day.
That's so important. They wanted to know if it was user-friendly, if the alerts and recommendations were actually helpful in real-world decision-making. It's about getting buy-in from the people on the front lines.
Makes sense. So after all that development, the testing, the feedback, what was the final outcome? What did this company actually achieve?
This is where it gets really exciting. The study quantifies some impressive results. First, a whopping 50% reduction in unplanned downtime. Think about that. Continuous production, fewer interruptions, a much more predictable output, that's a game changer.
50%, that's huge. And it has a direct impact on their bottom line, too.
Absolutely. And they saw a 25% reduction in their maintenance costs. That comes from optimizing those maintenance schedules, avoiding those expensive emergency repairs. It's about using resources, both people and materials, much more efficiently.
Significant savings. And it goes beyond just the immediate financial gains, right?
Yeah.
They're also extending the life of their equipment.
Right? By catching those early warning signs, they can address potential problems before they lead to major failures. That naturally extends the usable life of their machinery, which means they don't have to replace it as often. So that's a positive impact on their long-term capital expenditures.
And this ties into the sustainability aspect too, right? Less energy wasted, fewer resources needed for repairs and replacements.
Absolutely. It's a more efficient operation overall, which aligns with those broader sustainability goals. The case study really concludes by saying, look, this AI-driven predictive maintenance approach has the potential to transform the entire heavy manufacturing sector.
It's a powerful message. So for you, our listener, the person who brought this to our attention, the takeaways are pretty clear. Combining those IoT sensors, the AI, the machine learning, the real-time analytics, it's a potent mix. It allows you to move from constantly reacting to problems to proactively preventing them. And the benefits that this company achieved, that 50% reduction in downtime, the significant cost savings, the longer equipment lifespan, it really underscores the transformative potential here.
It's not just about the technology. It's about the mindset shift, embracing that data-driven approach.
It's fascinating. They've shown what's possible with AI in equipment maintenance. So it makes you wonder, What's next? What other areas of heavy manufacturing could benefit from this kind of AI-driven revolution? Could we see similar transformations in supply chain management? Maybe even dynamic production planning that adapts in real time to unexpected events? Or even achieving much higher levels of energy efficiency across entire facilities? It's a really exciting time to be following these developments.
There's so much potential still to unlock. It'll be interesting to see where this all leads in the next few years.
Absolutely. Well, thanks for joining us on this deep dive. It's been a really insightful exploration.
My pleasure.